Okay, in this video we're looking at an introduction to the laws of indices at the grade 5 level. And there's 5 laws that you need to know at this level, and we're going to begin with the multiplication law. So we'll go through each of them individually. You can make notes on what you need to, but without further ado, let's begin with the multiplication law. So this here, you've got 4 to the power of 3 times by 4 to the power of 5. There's a way of simplifying this, okay? But before we just kind of go straight into how you do this, let's understand where this comes from. So first of all, right, 4 to the power of 3, what does that really mean in long? It means you're taking your number 4 and you're timesing it by itself 3 times. So 4 times 4 times 4. That's what 4 cubed is. We're timesing it by 4 to the power of 5. So you've got 4 times by itself 5 more times. So 1, 2, 3, 4, and then 5. So in long, 4 cubed times by 4 to the power of 5 can be written like this. And you can see you've got the number 4, 1, 2, 3, 4, 5, 6, 7, 8 times. When you times a number by itself, okay, you can write it, in this case, your base number, okay, is this 4. So you're keeping it as a 4. And we can see we've got 8 of those 4s being times together. So the power, or the index, is going to be to the power of 8. Okay, so maybe you spotted, okay, to get this power up here, this 8, all we've done is we've added the 3 and the 5 to get the 8. And that is it. So the multiplication law for indices states, if you've got the same base, and what I mean by base is we've got a 4 and a 4 here, if that number, or it could be letter, okay, is the same, and you're timesing them together, you add the powers. So 3 add 5 is 8, okay? And this is the reasoning to why that is the case. So this one below, we've got x to the 4 times by x squared, okay? We now know, if you've got the same base, which we do, we've got x times by x, it's going to be x, and then your power, to get your power, you just go and add your indexes, or the powers. So 4 add 2, okay, so you could write it as 4 add 2, okay, but we can just go and say it is x to the power of 6, and that is your answer. And just to show you one more time, okay, the reason that is the case, because x to the 4, it means you're timesing x by itself 4 times, okay, and then we're timesing this by x squared, and x squared is x times by x, and you can see you've got x 1, 2, 3, 4, 5, 6 times, hence this power is to the power of 6, okay? So we now know, right, multiplication law, if you've got the same base, which again we do down here, okay, we've got to add the powers. So here we've got to go and do 4 add negative 7, so it's going to be our base, which is x, and then the power, or 4 add negative 7, if you need to, write it out, 4 add minus 7, okay, well 4 add minus 7 means 4 take away 7, which is negative 3. So you've got x to the power of negative 3. Okay, let's just highlight our answers just so you can see really clearly, okay, that these are the answers. So what you can do is you can try the 3 examples on the your turn. You can pause the video and I will go through them now. And just knowing if you're timesing, you're adding the powers. Okay, so the first one, right, we've got 3 to the power of 9 times by 3 squared. We now know if you've got the same base, which you've got to check, which we do, all you need to go and do is keep the base number the same and you add the power. So 9 add 2 is equal to 11. So 3 to the power of 11 is your answer. The one below, you've got algebra this time, you've got letters. It makes no difference because you've got the same base, you've got a y and a y. All you need to go and do is add the powers. So 2 add 5 gives you a 7. Last one, again, you've got algebra, that's fine, same rule applies. Okay, you've got your base, which is x, and you go and add your powers. Negative 2 add 6 is going to give you to the power of 4. Minus 2 add 6 is 4. So your 3 answers up here are 3 to the 11, y to the 7, and x to the power of 4. Okay, excellent. So in general, we can say, right, if we have 2 indices with the same base, so if they've got the same number here, which is 3 and 3 in this case, all you need to go and do is add together the powers. So 4 add 5 is equal to 9. To write this algebraically, because that's always a really good thing to do, we can state the multiplication law like this, which is if you take a number, a to the power of m, in this case, right, a is equal to 3. That's your base number, which is 3. If you times it by another indice, where your base is a, so again, 3, for timesing them, all you need to go and do is add your 2 powers together. So m and n, they can be any numbers. In this case, m is equal to 4 and n is equal to 5. All you do is you add together the powers. So it's a really good thing to be able to understand things algebraically. This is just your general rule for the multiplication law. So if you need to make a note of that, I would do. Okay, good. Moving on to the division law. And just like with multiplication law, I'll go through how it actually works, and then we'll just get into how you actually do the procedure. Okay, so this one here means we've got 3 to the 5 divided by 3 squared. 3 to the 5, again, if you write it out in full, means you're timesing 3 by itself 5 times. So 1, 2, 3, 4, and then 5. Very nice. So that's the first one done up here. We are dividing by 3 squared. And in maths, you can write dividing with a line underneath what you're dividing by. I'm dividing by 3 squared, which can be written as 3 times by 3. Okay? And then from here, we can go and cancel out some of the 3's. We've got a 3 on the top, a 3 on the bottom. We've got a 3 on the top and a 3 on the bottom. So we've simplified this, okay, down to where you can see we've now got 1, 2, 3's left. So we've got 3 is your base number to the power of 3. You're timesing that 3 by itself 3 times. So this answer is going to be 3 to the power of 3. And that is your answer. And maybe you spotted, okay, well, to get this, all you've done there is I've done 5, take away 2, which is 3. And that is exactly it. So for the division law with indices, if you're dividing with the same base number, so you've got a 3 and a 3 here in this case, and they must be the same number, you just take away the powers. So 5 take away 2 is 3. And that is your answer. So similarly here, we've got algebra, okay, but it works in the same way. We can just go and take away the powers because we are dividing. We're looking at the division law here. So this is going to be b, because that's your base number, b, and then we're going to be doing 7 take away 2, which is b to the power of 5, okay? So this stuff above here was showing you why, okay, we take away the powers. I'm not going to go through it in every case, you don't need to. Once you can understand it, you just need to know for division, you take away the powers. Similarly down here, we're dividing, okay, we've got the same base numbers, they're both x, which is important. So then here we're going to be doing x to the power of 5, take away negative 4. And this one, okay, let's just make sure we don't make any mistakes with this. We're doing 5 take away negative 4. If you're taking away a negative, okay, this goes to 5 plus 4. So it's going to be x to the power of 5 plus 4 is 9. So x to the power of 9. So these are the 3 my turns. So again, you can pause the video and you can give those 3 your turn to go, just knowing that when you divide with the same base, you take away the powers. Okay, so, right, this first one, hopefully we spotted, okay, I put it in here just to make us think a little bit. This one, we can't go and apply our division law, okay, and the reason is, right, these numbers here, this 2 and this 3, okay, they are not the same number, so we can't go and do 2 take away 4. So this one, right, we could work out the answer, you could put it into your calculator, but we can't use this law of indices, so we can't do this question. So a bit of a trick one there to make you think a little bit. But the one below, okay, we've got x to the 8 divided by x cubed. We can do this because we've got the same base, and we can go and do 8 take away 3, which is equal to 5. So x to the power of 5. Dividing, you just take away the powers. The last one, okay, your base number is the same. It is x, which is really, really important, okay, because we've got to check for that. And we're doing negative 2 take away negative 5. So we're going to be doing negative 2 take away negative 5. So x to the power. Well, negative 2 take away negative 5 is negative 2 plus 5. Minus 2 plus 5 is equal to 3. So that is your answer for this one down here. So you've got to be really careful with those base numbers. If they are not the same, you cannot apply your laws of indices. Okay, so in general terms, right, if we have a division like we do up here, if you've got the same base number, so in this case it's a 5, and you're dividing, you take away the power. So 6 take away 4 is equal to 2. So in general, using algebra, we can generalize this for all cases by saying if you've got the same base numbers, so some numbers a and a, in this case those numbers are 5, and you've got some powers where m and n, in this case, are 6 and 4, if you're dividing, you take away the powers. So that's your general rule. If you want to make a note of that, please do. Okay, so that's the first 2 laws. We're then looking at the power law, or raising to another exponent. So this just means you've got some indice raised to a power, like 3 squared, and then we're raising it to another power. How does this law work? Well, first of all, let's just go and consider this bit inside the bracket, okay, which is 3 squared. 3 squared you can write as 3 times by 3. Okay, so that's the bit in the bracket. We can write it in brackets here, again, if we need to. And because we're raising it to the power of 5, this means you're timesing your number, which is 3 times 3, by itself 5 times. So we've got to repeat it 5 times. Okay, so we're going to go and do this. In total, 5 times. So 1 is there. We're going to do it again. So 3 times 3, that's 2. We do it again. 3 times 3, we do it again. 3 times 3, we do it again. And then 3 times by 3. Okay, it's the same way that if you went and did, I don't know, 4 to the power of 5, that would be 4 times by itself 5 times. The same thing here. We're doing 3 squared, which is 3 times 3 times by itself 1, 2, 3, 4, 5 times. And if you wanted to, you could go and remove the brackets now. That was just to make things clearer to what was going on. Okay, so let's go and get rid of those. And then you can go and count, well, how many 3s have you got in total? You've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's going to be 3 to the power of 10. So the general rule here is if you've got some indice and you're raising it to another power, in this case to that 5, you multiply the powers together. 2 times by that 5 is equal to 10. So that is your answer, 3 to the power of 10. And this stuff here, this is showing you why that is the case. Okay, so now knowing this, right, we've got our indice here, x cubed, and the power is to the power of 22. Definitely, I'm not going to show you that the working for this will be here all day. You just need to know now that you've got an indice raised to another power, you multiply the powers together. So 3 times 22 is 66, so it's going to be x to the power of 66. And that is your answer for this one. Okay, again, this stuff here is just showing you the reasoning to why we multiply the powers. Similarly, the last one, you've got 2 to the 4 to the power of negative 5. Again, we just multiply those two powers together. So it's going to be 2, and you've got 4 times negative 5 is going to be negative 20. So 2 to the power of negative 20. That is your answer for this last one. Okay, so again, you can pause the video, give those 3 a go, and then we can move on, and then we can look at the next law. So this one here, we've got 5 to the power of 3, all to the power of 4. Again, for this law, we just multiply the two powers together. So it's going to be 5 to the power 3 by 4 is 12. So 5 to the power of 12 is your answer. Next one, again, algebra makes no difference. You take your base, which is y, you multiply your two powers together. So 2 times 6 is equal to 12. That is your answer. The last one, again, our base number is 4. We've then got that negative 4, and we're timesing it by negative 3. If you're timesing two negatives, it makes a positive. So 4 times by 3 is to the power of 12. So we can see, okay, just by coincidence, all of the powers here are to the power of 12. That's just coincidence. Okay, so again, putting it into general terms, we can state this. If we take a indice like 5 squared and we raise it to some power, we just multiply the powers together. So here we take a number a, in this case that number is 5, the power m, in this case is 2, we raise it to another power, which is 6, we multiply the powers. Okay, in maths, if you've got things grouped together, mn, this here means you're doing m times by n. In this case, that would be 2 times by 6. So this is your general rule for all cases for the power rule. Okay. On to negative powers. Right, with negative powers, really, really important. You need to know that if ever you see a negative power, the first thing that you need to do is you need to go and take the reciprocal of that number. Reciprocal means you go 1 over your number. So in this case, the number is 2. So whenever you see a negative power, you take what we say the reciprocal, okay, in maths, so reciprocal, which means you go 1 over that number and you raise it to the power that is given. In this case, that is to the power of 1. Well, to the power of 1, it just means by itself, so 1 over 2. And that is your answer in this case. Okay, if you wanted to sort of see why that is the case, we can look at this in more detail. If you think, okay, that's fine, I now know that's the case. Okay, so the one below, if we had 5 to the power of negative 2, because you can see a negative power, first of all, you go 1 over your number, which is 5, you raise it to the power, which is this 2, so 1 over 5 squared. Okay, well, 5 squared is equal to 25, so 1 over 25, that is your answer. Okay, so that is the rule. If you want to understand why that is the case, then I would listen into this, because this shows you why this is the case. If we look at 2 to the power of negative 1, and we write it differently, let's write 2 to the negative 1 like this. So that's going to write 2 to the power of 2 divided by 2 to the power of 3. So I'm just showing you why you take 1 over your number. Okay, and we now know from the division law, okay, 2 squared divided by 2 to the power of 3, if you're dividing with the same base, you subtract the powers. So 2 take away 3 gives you 2 to the minus 1. So I've just rewritten 2 to the minus 1, okay, in a different way. I've just chosen this way to write it. Right, but that's now going to consider, right, this bit, okay, looking at it sort of in long form. 2 squared, it means we're doing 2 times by 2, and we're dividing by 2 cubed, which is 2 times by 2 times by 2. Okay, and we know that that is equal to 2 to the power of negative 1. Using a little bit of cancellation, right, we can go and say, well, this 2 cancels with this 2, this 2 cancels with this 2, and we've just got this 2 left on the bottom. Okay, so really, what we said here is, right, we've got these 2's cancel and these 2's cancel, right, and they cancel to make 1, because effectively you're doing 2 times 2, which is 4, over 2 times 2, which is 4. 4 divided by 4 is equal to 1, okay? So you've got 1 over 2. You've got 1 over 2, which is equal to this 2 to the minus 1. And that is where this 1 over 2 comes from, okay? Again, this bit, if that doesn't quite make sense, the way you can think of this, well, 2 times 2 is 4 on the top. You've then got 2 times 2, which is 4, times by 2. Right, these 4's, they cancelled. Well, 4 divided by 4 is equal to 1, and it's over that 2 still, which is why we get this 1 over 2, 1 over 2. So that is the reasoning to why, okay, if you take a negative power, you go 1 over your number to that power. If that's confused you, don't worry about it too much. If you get that, that's really, really good. Okay. The last example, same rule. You've got a negative power. Negative power means you take 1 over your number. In this case, your number is a letter. That's fine. It's x, and you raise it to the power that is given, which is to the power of 4. And that is your answer in this case. So actually, applying the rule is really quite straightforward. But this here is understanding what is going on, which could be a really good thing to look at. Okay, so what you can go and do now is you can pause the video. You can go and try those 3 your turns. I'm actually going to go and get rid of this working over here just because it kind of gets in the way a bit, doesn't it? So let's get rid of all of this. Okay, so let's go through these now. The first one, we've got 8 to the power of negative 1. Again, you see a negative power means reciprocal. You go 1 over your number and you raise it to the power that is given, which is a 1. Okay, 8 to the power of 1 is just equal to 1 over 8. And that is your first answer. Next one, you've got 4 to the power of negative 3. Again, you see a negative power, you go 1 over your number, which is 4. You raise it to this power, which is to the power of 3. And then we've got, well, what's 1 over 4 cubed? Okay, this here, it means we know 4 times 4 times 4, which is equal to 4 times 4 is 16, times it by 4 again is equal to 64. So 4 cubed is the same thing as 64. Okay, and that is your answer for this one, 1 over 64. Good. We've then got y to the power of negative 4. Okay, negative power again, you go 1 over your number, which is y. You raise it to the power that is given, which is to the power of 4. So 1 over y to the 4, and that is your answer. Okay, excellent. Good. Okay, so in general, right, the rule for the negative power rule is if you have some number a, okay, in this case, a was equal to 3. If you raise that to a negative power, to some number, so like negative 4, you go 1 over the number. Okay, so in this case, our number is 3, and you put it to the power that is given in the question, which was 4, and which was 4. Okay, on to the last rule at the grade 5 level, which is the 0 power rule. So what about 3 to the power of 0 or x to the power of 0? Okay, well, anything to the power of 0 just gives you 1. So if we go and take 3 to the 0, it is equal to 1. Okay, if we go and take x to the power of 0, it is equal to 1. So anything to the power of 0 is equal to 1. The reason is, we can go through it now if you want to go through this, which I think is a really good thing to see. If we go and wrote something like this, okay, like, I don't know, we could go and rewrite 3 to the 0 as 3 to the power of 3. Oh, what's happened there? That's not good. 3 to the power of, oh, sorry, I'm not quite sure what is going on. 3, what is happening there? Sorry, had a little bit of an issue. That's strange, it's really strange. Okay, sorry, 3, that is very, very strange. Am I writing in the wrong place? That's, sorry about that. Anyway, right, 3 to 0 we could go and write as 3 to the power of 3 divided by 3 to the power of 3. And that is equal to, dividing by the same base, we can go and do 3, take away 3, which is equal to 3 to the power of 0. So that's from our division law. I've just rewritten 3 to the 0 in a slightly different way. And again, we know that we can write this, well, 3 to the power of 3 is going to be 3 times by 3 times by 3, and we're dividing by 3 cubed, which is 3 times by 3 times by 3. And then what's going to go and happen here? Some cancellation. Right, this 3 goes with this 3, this 3 goes with this 3, this 3 goes with this 3. In effect, what you're really doing is you're doing, well, what's 3 times 3 times 3? It's 27 divided by 3 times 3 times 3, which is 27. 27 divided by 27 is equal to 1. So you can see that 3 to the 0 is equal to 1. And this is the reasoning to why that is the case. So anything to the power of 0 gives you 1. And in general terms, okay, we write it like this. So a, any number, it could be 3, it could be x, it could be a million, to that power of 0 gives you 1. So in summary, we looked at 5 rules, okay? And they were this: the multiplication law, which you can go and see there, division rule, power rule, negative power rule, and then anything to the power of 0 is equal to 1. And that is it to the introduction at the grade 5 level for the laws of indices. Thank you.